list of attendees I've got, I think most of you are here. There are a few who are not yet, but I'm not going to hold out for them necessarily because I'm sure they'll join us shortly. Before we begin, I always ask this question just at the very beginning just to make sure that you can hear me correctly. My control panel is suggesting that my microphone is working. That doesn't necessarily mean that you can hear me. There is a question box, and I think some of you have already popped into it. Thank you very much, Holly. That's great. Just to confirm that you can hear me, which is good news. Very good news. Let me just move that out of the way. And yeah, we've only got a 1 hour session to run through this. There's an awful lot to cover. Trying to talk about the entire kind of coding structure underneath an ASP.NET app in an hour is challenging to say the least. So without too much further ado, I'll get cracking. Just a little bit about the session, how it runs. I'm sure many of you have done IronSpeed webinars previously, so this is old hat to you to some degree. You have centrally muted you all, such that as a result of you joining, we don't get sort of audio feedback if people have got open speakers at their end. That being the case, the only way you can communicate with me or with Jill, who's moderating today, is via the question box. Now, I know some of you have already pinged a message in there to say that you can hear me, which is good. That is, unfortunately, as a consequence, the only way that you can let us know anything. One thing to mention there, though, is that any questions that you fire, please don't save them up to the end. There will be hopefully a little bit of time to answer some questions at the end, but there's no need on your part to wait for that. So if you do have any questions as we go, please do fire them in. I will do my best to answer them immediately. If I can't, it's possibly only that I know that something we're about to cover shortly might answer your question. They get kept in a log here so we can see them all. So please don't feel like we're ignoring you. We're not. Okay? So just any questions at any moment, fire them through, and I'll do my best to answer them for you. What are we running through today? As I say, we've only got an hour for the session, and the agenda or the topic is a sizable one to say the least. So there's an awful lot to cover. We may we almost certainly won't be able to go through everything on that list in specific and incredible detail. Clearly, the .NET code model is something you could probably talk about for a month if you wanted to. So we're going to talk a little bit about the .NET code model. We're going to look at the life cycle of pages within ASP.NET and how they fit together and the various sort of stages at which you can intercept them. We're going to talk a little bit about client-side versus server-side code. If you are only an IronSpeed developer and you're not someone who's begun to tinker with web applications in general outside of Designer, the concept of or the split between client and server-side may not be immediately obvious to you. It may not make immediate sense quite what we're talking about there. As well as, of course, there being this sort of client-side versus server-side argument where our application code sits. There's obviously things such as Ajax, which possibly sits somewhere in the middle in terms of asynchronous coding. We'll talk a little bit about master pages. Master pages have been available within Design for a long time now, but just to understand what they are and how they fit into your app and how to use them. The concepts of end-tier applications, which frankly possibly could be at the beginning of the session, but we'll talk a little bit about what we mean by an end-tier application. And then we'll touch upon MVC. Now, IronSpeed Designer, as it currently is, generates ASP.NET Web Forms applications. There is obviously an alternative technology within .NET called MVC. We're only really touching upon there the fact that, broadly speaking, the concepts of the way that Designer generates code do reflect a similar kind of structure to the MVC product. We'll talk a little bit about what Designer gives you. Of course, the reality is that Designer generates the vast majority of everything that you see within that agenda for you. But if you are new to coding, so you've possibly been using Designer for some time, but you're just starting to write custom code, then whilst all that's there, you may not be appreciative immediately of everything that Designer is already doing for you. So we're going to look at that. So, as I said, please, if you have any questions, if that agenda is at odds with what you were hoping for, anything like that, hit me in the question box and I will do my best to answer your questions. So first of all, we're going to look at the ASP.NET code model. Now, depending on how old you are or are not, you may be familiar with Classic ASP, which came along before ASP.NET. Classic ASP approached the nature of the structure of building code very differently to the way that we do now, typically speaking, within ASP.NET. And the way that used to work, Classic ASP used to effectively give you one file, one ASP file, and in that file we used effectively that file incorporated both the HTML markup for a page as well as the code which would sit behind it, as you can see from that example there. Of course, that becomes very problematic to maintain as pages get more complicated, and it's a dramatically more awkward structure to maintain. It also means that effectively you might be writing code which is common across your application in every page. So you don't have the class structure and hierarchy that you might be familiar with in any other .NET application. So Classic ASP, there's still nothing to stop you writing your code directly within script tags in markup if you want to. And clearly for things like JavaScript, to some degree we are still doing that. But clearly now in most cases you would not write either your VB or your C# code within the markup of your page. So ASP.NET changed the game very much in that effectively, as well as effectively we had a separation of the markup of a page from the code, or the functional code that ran on the page. And that's largely done via this code behind page model that we now use. So within this code behind structure, we've got this separation of the layout, that's the HTML markup that the page is going to render in a browser, and the code that is going to be running underneath the page. That code that's there is now called a code behind. And you can see from that little indicator or image on the top there, this will be something that you'll see if you pop open the plus signs in your tree views within Designer. Underneath an ASPX page, you'll have an ASPX.VB or .CS file, depending on whether you're writing with Visual Basic or C#. The ASPX file contains effectively the markup structure and definition of the page, and all of the code, the functional code, such as the reading of SQL data and the binding of that data to the page, has been removed from the ASPX markup file and placed in this separate code behind file. There's no performance difference there, but the main reason for doing that, amongst other things, of course, is the fact that that code now can inherit classes from other modules and code elements within your application. So you're not having to write the same code in every page if it's common and is being used in multiple different places. Of course, if you're working in a team where you've got graphic designers or UX designers, those people can be working on layouts. Developers can be writing code. So you can both be maintaining those two files differently. Designer, of course, makes it so easy to maintain an application. The likelihood is that you'd be using, potentially in this case, in most cases, I suspect it's probably you. You would be able to design your layout, and effectively designers maintaining a lot of the basic code for you on that page automatically. But within ASP.NET, that separation of markup from code effectively means that you could have a user experience or user interface designer working on the markup and the layout, and other developers writing the code that's going to sit behind that page, and the two don't really need to interact with each other as long as the control structure of the page is not changing, or in terms of the content of the markup. So that's quite a powerful feature. Effectively, the functional code now running behind a page is not interested in any way with how that page is being presented. That's where we begin to understand the notions and ideas behind what is commonly referred to as an N-tier application. By N, we simply mean that there's more than one layer of an application. Designer, of course, automatically generates you N-tier applications, and if you look in your application explorer within Designer, you'll see that Designer is generating you a data access layer, a business logic layer, and a presentation layer automatically. So that's taking this idea of the separation in terms of logic separating the way that something is presented and the way it looks from the function that that may have, and taking it to another level. So that's how ASP.NET was, the structure of it, very loosely speaking, tends to sit. You will also notice within your Application Explorer, depending on whether you're building a web application or a website, that if you were to pop open, for example, the Show Orders ASPX page, you might see another file under there, showorders.aspx.controls.vb. Now those two code files effectively are partial classes. Together they define all of the code that sits underneath show orders. The only difference is that the controls.vb file concerns itself with the code methods for the individual controls on the page, whereas the main code behind file, which is the aspx.vb or C# file, concerns itself with code elements specific to page level interaction. Okay, so that's the only difference between them. You'll notice if you look in the code at the top, they're both defined as partial classes. So they are required in combination to produce all of the code class for that page. So just looking, if you were to look in the ASPX content, this is obviously being done in Visual Studio. To some degree, Designer intentionally doesn't present you with the raw ASPX content for your page. You're meant to be maintaining that using the quick layout editor rather than using the ASPX file itself. If you do update those ASPX files, Designer will overwrite your changes because your changes aren't meant to be made directly to ASPX content. However, you are of course free to have a look in there and just see what's in the file. Just out of interest, Designer obviously is intending to make it much and dramatically easier for you to maintain that file by presenting it to you graphically. But just in the instances of being understanding and talking a little bit about the constructs of ASP.NET, you can see here that in an ASPX file for any page, we tell and define in there the code file, the code behind file that's going to sit and interact and is related to this markup file. So that's all this is showing you, that the two are related, and we understand that they are as a result of that code file tag that's inserted and maintained in the ASPX file. So that's how your project understands which code relates to which screen or page. The code behind is derived from the page class. Now this is where the real power begins to come in terms of how you can construct your pages within the project, within your IronSpeed Designer application. The vast majority of your pages within an app will contain common code. So that's code such as reading data from a table, providing the various code methods to handle the different elements of the page lifecycle. Now these are standard. And if you begin to look through the constructs within either Visual Studio or just within the file server, if you look in the shared folder, you'll see that there are a number of folders in there, of files in there, one of which is called base application page. And that's a kind of lower level page class that is common then across all of your different application pages. And as a consequence, when you see the way that Designer constructs the page code methods, you'll see that in this case, our show categories table class is inheriting from base application page. So rather than having to create copies of all of the different methods and functions that are existing within base application page, by using the inheritance model of .NET, we can automatically inherit from them, so we don't have to keep writing them for every page. So it makes your application dramatically easy to maintain. If you do want to extend the base application page class, you're perfectly right to do that. You can do that using either Visual Studio or Designer. And of course, then you know that if you were to extend that or extend any of the methods within base application page, all of your other pages, because they inherit from that class, will automatically have access to that extension. Okay, so the best practice of the .NET code model, or why it was done, we use this code behind page model, so we've separated the logic of our page and the function of our page from the markup and the rendering of the page. We've derived the page from these common classes so that we don't have to keep rewriting the same methods, and that if we do want to update any of those or extend them by using inheritance, we can pick that up across the application automatically rather than having to rewrite it numerous times. That's an awful lot to swallow if you're new to .NET coding. I'm very aware of that, and I feel a little like I'm racing through this because we only have an hour available. So do please let me know if that makes sense, or if it doesn't, or if you want me to reiterate any part of that before we move on to the page lifecycle. If you don't pester me in the question box, then I will hopefully assume that that's going in and is at least comparatively clear, if somewhat run through quickly. Okay, that's good news. It looks like, broadly speaking, you're with me, which is great. Okay, good news. So let's talk about the page lifecycle. Page lifecycle is something which, if you are an IronSpeed developer who's just starting to get into or hoping to try to write custom code, can't stress enough how important it is to understand the page lifecycle. And there are two different elements to that in terms of that understanding. One is the generic understanding of an ASP.NET page and its lifecycle. So that's generic, and that would be generic if you were writing, hand coding your ASP.NET application. Then there is in addition to that, the lifecycle of an IronSpeed designer generated page. And when you have a full understanding and you feel comfortable with that page lifecycle, both the ASP.NET generic one, if you like, and designer's particular stance on it, you will immediately begin to see that by using, in most cases, very few lines of code, you can dramatically enhance the functionality of your application. So I suppose I'm saying in a rather roundabout way, the classes and the structure that designer generates for you underneath all of your pages is extremely comprehensive and thorough in its structure. It might initially be rather difficult to grasp, but once you do, you will begin to appreciate quite how useful that structure is and how easy it makes your life when you come to modify code. Within Astudillo, we have a rule of thumb we call the rule of 10. Basically, we're saying there that whenever we start to modify code for a fairly simple code modification or customization, we have a rule that once we start to write more than 10 lines of code, we ask the question whether we're writing that modification in the right place. And by place, I mean place within the life cycle of the page. Now, of course, there are customizations we've done. We've had to write many thousands of lines of code. But broadly speaking, if you're writing something simple, when you get to the point where you're writing more than 10 lines, do ask yourself that question: am I sure this is the right place in the life cycle of the page to be doing this work? Because it's quite incredible how much you can achieve by writing less than 10 lines if you're writing them in the right place. It's something worth thinking about. So, what do we mean by the life cycle of a page? Well, hopefully that part is comparatively straightforward, even if you're not, as a concept, even if you're not particularly familiar with the detail. So we're talking about what the page does and the sequence of events it runs through from the point that a browser makes, a client browser anywhere makes a request to a web server and says, please deliver me this URL. At that point, the server goes through and runs a number of different events in order to produce that file and transmit it down to the client browser. So it's obviously going to initialize the page. It's going to load up the interface controls and begin to build them into the HTML. It might be reading data from the database. It's then going to bind that data to the controls that are going to be on the page. Of course, that would be different if it's a browse or a show page from an edit page, etc. And then ultimately it's going to produce an HTML file which is going to transmit down to the client server. Don't forget, HTTP is a stateless protocol. So at the point that that page is served, effectively the server forgets all about you being the client in this case. So that, to some degree, you could argue, is the end of that life cycle. Of course, it isn't fully the picture at the end of the life cycle, because if that page is an edit page or an add page, we may well get data back. So we're going to be then having that page posted back to the server. We're going to have our view state included within the page or sent back or stored in SQL, which will then identify that user. So we, at that point, our stateless protocol is going to kick back in and remember that we have interacted with this user or client before. And we're going to pull data out of what we've received from the browser. We're potentially going to validate it. Assuming that it's valid, we might be committing data back to SQL. We might be redirecting to a different calling page. We might be staying on the same page, whatever that might be, but certainly we're going to understand where that user is going to navigate to you next. Okay, so there are, in effect, when we're talking about page lifecycle, there are almost two different sides to the page lifecycle. There's the point at which we are serving a URL on request from a client browser, and then there's the point where that client browser has submitted data back to us, and we might be retrieving new values from what they've sent and potentially committing them to the database. So .NET handles the loading of the page. It converts these ASP controls, which are the ones that we're using within Designer. It converts them to HTML. It's going to render those controls on the page. But obviously within that lifecycle of the page, the various different events are running. .NET raises these events, and these are hooks that you can attach event handlers to. And those event handlers are then going to enable you to intercept that page at various stages within its lifecycle, if you so choose, to write code within there to customize what .NET's going to do on your behalf. Okay, so within that lifecycle of the page, of the different events that are running, those events, as they fire, effectively have handlers that you can intercept. So when we begin to write code against our application, or if we're going to write custom code, of course, don't forget, I'm talking about writing code like the code doesn't already exist, which is possibly not entirely helpful. This code is all there. Designers generated it all for you, and that's obviously how and why your application works to begin with. But that code that's sitting there within the .NET model, these event handlers sit there and are available to you so that you can begin to customize what's there in addition. Okay, so when we talk about writing an event handler to, let's say, handle the page load event, the truth is that page load event already exists. Designers generated that code for you. All you would need to do if you want to override it or mend your own and put additional functionality in there is identify that load event code and then provide customization to it. Okay, so initializing a page, the display effectively has three major events: initialization, load, and pre-render. Of course, depending on how complex the page is, both the init and, in fact, all three of those, but particularly the load event, may well have significant complexity in there while it reads data for all of the different record and table controls that might be on the page. So let's drill it down a little bit further, refine our view. This is a little bit more detailed version now. We've got down to individual real code name methods that would sit within your page. So if I'm just going to grab my little highlighter pen. So if on the left-hand side, we talked on the previous slide about the fact that there's init, load, and pre-render. So those are still there. But as you can see, within particularly the load event, there's an awful lot going on within what we generically class as load. Now, one of the things that Designer helps you with that's often overlooked and not really considered to be as helpful as it is, within the docs method, within the documentation, you'll see that there's a lot of documentation in there which is actually automatically maintained to reference the real controls on your own pages rather than just being generic, to give you this detailed breakdown. And that, indeed, this is where this is the slide that we're looking at now is from. I'll possibly mention that a little bit more as we get to the end. But just to give you an idea, these are the basic methods then that would run in that first phase of a page. So at the point that we've been a URL's been requested of our server, the server's going through and producing a page to render back down to the client browser, this is what would happen. Now the key parts, the sort of darker orange methods on there, which are effectively shown in this key at the top, are row or record control class methods. Those are the methods where you would do most of your customization if you did want to customize this page, as an example. So you might customize the load data. You might customize create where clause for any or all of the controls that are on that page. A key one that you might override is the data bind. Now don't forget, within here, depending on what fields are in here, there'll be set methods as well for each of the individual fields that are on there. You might want to override those. So there are numerous levels of detail beneath even the methods that we're looking at here, which go further down the construct of that page. Understanding the order that these events fire and where you would be placing your code is the critical bit of why I was referring to that rule of 10 that we try and make sure we remember. So yeah, I'll leave it at that for the moment. Seem to not be able to move the slide forward all of a sudden. Here we are. Sorry, don't know quite what happened there. So after displaying a page, what happens? Well, as I mentioned, HTTP, or indeed HTTPS if you're running under SSL, they are stateless protocols. At the point that that page is transmitted down to the client browser, the server releases that page and it knows nothing about it, forgets all about your existence. So the state information is maintained in what's known as view state. And in most cases, view state is a section of memory content which is posted down in the HTML of the page. If you're looking in your browser, you're looking at an IronSpeed application, you right-click and do view source, you'll see this big section of gobbledygook at the top of the page, which is the view state. You don't have to store view state in the page, and depending on the performance of your application, the specifics of what you're running, you can maintain view state differently, so you can store it in the session variable, you can store it in SQL, etc. By default, Designer will store view state in the page markup. Now, what is in the view state? Well, there's an encrypted version of all of the different values of the controls, etc., and your identity, by you I mean the client browser, that is being held within there, such that when you fire a post back and that hits back to the server can interrogate that view state and ensure and remind itself, if you like, of who you are and what you were doing, which introduces us and enables us to talk a little about the concept of a post back. Now, I don't know whether you're familiar with the concept of a post back, you know, the idea behind it and what it means. What is a post back? It's effectively any interaction by the user which is going to cause view state to be and the page to be sent back up to the server. So in most cases, you'll fire a post back, for example, if you were to click the save button on an edit page. At that point, your browser is effectively sending that page instance back up to the server with an updated view state. The server is going to intercept that page, interrogate view state to understand what needs to be done, and then run a number of run the full second half of the life cycle of that page on the server for you. So what does that look like? It looks a little bit like this. So when our postback has been fired, we're going to run another initialize system. We're also going to read a load again, but this time any or all of the events which caused this postback are going to be handled by an event handler again. So there's an extra box, this event handler box, which is saying, okay, well, what caused this postback? How did I get back here, and what, if anything, do I need to do now? So let's drill, as we did with the earlier slide, for the first side, if you like, of the life cycle. Let's drill further down. Now, in this case, you'll see that the load, effectively, the load has done very little, and this is showing us if someone had clicked the save button on a page. So we're not necessarily immediately rebinding our UI data at this point, but because someone clicked the save button, we're going to be intercepting the handler for the save button click. And so in this point, we're going to run the base version of that method if we haven't customized it yet. We're going to open up a SQL transaction because we might need to commit data back to the database. And then we run the save data method. And in that save data method, again, we can drill down further in there. There's a number of different methods that run. The first thing we do is a load data. Why do we do a reload of the data if we're going to commit it back? That's to ensure that in between this page having been served to that client browser and us now receiving an updated version of the record to commit, that data hasn't changed. So a checksum check is going to be performed there just to ensure that in terms of database contention or concurrency, that nobody else has changed this data in the meantime of us looking at the page. That's why we run another load. Then we're going to validate that data. Now, that's a very strong or commonly modified area. You might be suggesting, for example, that if someone needed to enter a date for an invoice or something like that, you might want to check that that date is at least today's date or maybe in the future, and they couldn't enter a date in the past. So that's where you might modify that kind of code. And then the last thing we do is we do a get UI data. So at this point, much in the same way as on the first pass of the page, we bind SQL data to controls on a page. This time around, we're pulling data from controls on a page into memory such that we can bind them to the data source and then write them back to SQL. Okay, so it's broadly similar, but is of course a slightly different life cycle in terms of the classes that are executed. So during a postback, there is a concept within .NET called isPostback. And so in there we can determine whether we are being posted back to on this page or whether we're not. So as an example, we can improve the performance of a page by using this isPostback section and indicator so that common methods such as loading the data on a page initially, we would only ever do that if we were not posting back, i.e. if this is the first time that we've rendered this page. And if we are doing a postback, then we possibly wouldn't reload all of that data. So you can use that construct as well. Talking about ViewState, ViewState, as I said, is a standard feature of .NET. By default, Designer will put it in the HTML cent, and that's what it looks like. Okay, so it's a bit of a big mess. You can't immediately interrogate it, but critically, it is not encrypted. So it's encoded, but it is not encrypted. If you need to have your ViewState encrypted, then you will need to run your application under HTTPS, not HTTP. You need to install an SSL certificate on your server. So it might look like it's encrypted, but it is not by default. So as I mentioned earlier, you can, although your ViewState is being stored in HTML by default, you can move it. The main reason to move it around, or people do move it around, is for, to some degree, is for longevity. So if you were to store it in the database as an example, whenever your users log back in, your application could immediately remember where they were last time, as an example. But you will need to do some work to move that around depending on where you do want to store it. By default, Designer leaves it in the page, which in most cases is almost certainly the right way or the right place to put it in terms of the balance between performance and the ease of maintenance. So best practice of the page lifecycle. Do most of your work by, I would actually go a little bit further than saying handling the load event, and I would just say, by and large, you should try to use the existing methods that are there for your customization. And by and large, I would try to do your customization as high up within that hierarchy of the class structure as you possibly can. No one's asking any questions, which worries me. Maybe it shouldn't. So further sessions, make sure you decide where you're going to store your view state. So it's persistence is the word I was looking at earlier. Yes, it's view state. Unless you store it in SQL, is not persistent. Cookie, you can obviously store it in a cookie, which will mean that if someone is accessing your app from the same machine, then you can obviously use persistence there to remember where they were. Clearly, if they were to log in from then a public computer or something, that would not be the case. Okay, let's talk. Let's move on then. Thank you for letting me know you're still with me, Holly. It's much appreciated. Let's talk about client and server-side code. Now, I am going to ask, just see whether anybody is happy to comment here. Are you familiar with what I mean, what we mean by client and server-side coding? Because when you write code within Designer, and virtually all the code that Designer writes for you and generates for you is server-side. And introducing client-side code begins to make an ASP.NET application, whilst it can make it functionally much richer, can introduce enormous complexity. Okay. Most of you aren't immediately sure about the difference between the two. Okay, so when by server-side code, effectively I mean, and I'm referring to any code that you write within your application, that you'd be writing in either VB or C#. The fact that you're writing in VB or C# guarantees that that code is going to be running on the server. And that's true even if it's Ajax, or effectively Ajax initiated code. Client-side code is exclusively written in JavaScript. And that JavaScript gets sent down to the client browser in the HTML markup of the page at the point the page is served, and can run and use the CPU power, if you like, of the client machine rather than the server. So I'm trying to think of a really good example now. If, for example, you were to send a page down to an IronSpeed generated page down to your browser that had a Google map, an embedded Google map in it, you would be aware that that Google map, that the user can scroll around in the map. They can move it around. At that point, the server, your application, knows nothing about what's happened to the map. It knows what the map looked like at the point that the page was served and sent down. But all of the code then that is enabling that user to scroll across and go to a different side of the country or zoom in or whatever it is, that's all happening in their client browser. It's not, your server isn't aware of it until potentially a postback gets fired. So client-side code is JavaScript code. It is not VB or C# code that's running back on your server. Now, the challenge in today's web development world is that many of your users, your customers, will all be using applications which use either asynchronous coding, so methods like Ajax, or use heavy JavaScript client-side code to enhance the user experience on a page. So I'm thinking of an application, a website, I don't know, LinkedIn, for example. There's an awful lot going on within a standard LinkedIn page which is actually running on the client. So you wouldn't necessarily need to fire full postbacks to interact with the page as you might. Now, simple things that you can do with JavaScript is simple things like client-side validation. So, for example, if you're probably familiar with some websites where if you're typing in a password, let's say a system's asked you to set up a password, the page might dynamically give you a little colored indicator to tell you whether the password you've entered is significantly complex or not. That's running on your browser. That's JavaScript. Your server application wouldn't know anything about what you typed in that box until you do a postback and try and commit it back to SQL, as an example. So that's the kind of stuff that runs client-side. The challenge that we all face, if you're common developers, which I'm sure you all are, is that the competition make it difficult for us because some of this code is remarkably complex. But unfortunately, your users and your customers are increasingly using applications on the web with a fairly heavy client-side component and more feature-rich functions as a consequence. So it's a challenge. Server-side code, a little bit more simple. It executes on the server and it sends data down to a client browser potentially. It's got obviously access to the data access layer and the business layer. It's obviously got these strongly typed classes because you're writing within .NET, and it executes after client side when a postback has been fired. So the critical part here is that there is, if you like, effectively this third option, which is AJAX. And if you've ever heard of AJAX, AJAX stands for Asynchronous Java and XML. And in effect, all this means is that you can have client-side code, which does operate asynchronously. And by asynchronous, all I mean is that it doesn't need to fire a full postback, but it can still retrieve data from your server. A good example of this, if you use it on the web, use the Google, any Google search page. As you're typing your search criteria, you'll see that Google's got this automatic suggestion feature which is popping up underneath. Now that's asynchronous code, and of course Designer automatically builds you in some asynchronous functions. So if you use the type ahead function, for example, on a search box, you'll see a suggested solution list popping up underneath. That's asynchronous. So no, you're not firing a post back, it's updating as you type. That's the kind of thing we're talking about when we're talking about AJAX code, asynchronous access to data. Strictly speaking, client-side code, JavaScript, does not have access to SQL data. So it has its own limitations, although it may be fast because it doesn't have to go back to the server, and it may be quite powerful in its own right. It doesn't have access to the data uniquely or initially without the use of some kind of asynchronous element. So what's the order of execution? How does this work? Well, initially, of course, if you haven't served a page down to a client browser, then it can't have any, they don't have any client-side code to run anyway. So at the point that a page load runs, your server-side code is running, it's building an ASPX page, and it fires it down to the client. At that point, that page could include JavaScript. Okay, and that JavaScript might be AJAX JavaScript or otherwise. At that point, having released control of the page, your stateless protocol's ended. At that point, client-side scripts and JavaScript could be running in the client browser. When we talk about AJAX, AJAX runs within what are known as AJAX panels in your pages. Designer automatically includes these for you. So you don't have to worry about coding them. They're automatically there by default. Effectively, all this means is that your browser, or the client browser, has an understanding of individual areas on a page which may invoke these asynchronous postbacks. So that's known as a partial postback. Partial because it's only part of the page rather than the whole page. And as a result, that little page that sort of component of the page within the panel can update without having to require that full postback. So you'll notice this if you're interacting with a show table page within Designer, for example, and you type search criteria, you'll notice that the panel updates and you don't see a full postback fire. You can turn that off within Designer very easily if you don't want to use AJAX panels, but you very easily, well, Designer will include it for you by default. So Designer does an awful lot to try to help you in the kind of battle of trying to make your pages more interactive and less clunky with the full postbacks. An example of that is the spinning dialogue that you get. That's what I was referring to. If you put search criteria in, you'll see the animation of the flower or the spinner, whatever you want to refer to it as, within your page. That's AJAX running. So you're not running a full postback. You'll see that little spinner just while the asynchronous partial postback goes and retrieves your next set of data. So what are the best practices for using AJAX? By default, Designer builds you one AJAX panel per page. You can use many more if you want to, but it can become increasingly complex to maintain them because they may be dependent on each other. So that's something, if you've used the Telerik ASP.NET controls, they are extraordinarily powerful. They're also extraordinarily difficult to configure. There's a thing in there called the RAD AJAX Manager, which would enable you to configure those more easily, but it's still complex. So by default, Designer tries to make your life a little bit easier by just giving your page a single update panel. Any more questions on Ajax? I know I've said it earlier, but I'm obviously aware we are racing through some extraordinarily complex subjects. I know this is only meant to be an overview of the model, but do please hit me with questions if you need them. Let's talk about master pages. Master pages, although they've been in Designer for a long time now, they were very, very well received because they give you enormous power to customize your app without having to do a lot of legwork. So before master pages, if you wanted to change the headers on your page, it might be that you were using ASX controls to do that kind of thing, but if you were not, then you would clearly have to visit every page and change the structure of that page individually. Master pages make that vastly easier because in effect you've got one master page and you can customize that master, and all of the master page changes that you've made would automatically get applied to child pages, as it were. So it effectively enables us to build this consistent layout, centralizes these common functionality, and makes everything a lot easier to maintain. So within Designer, master pages have got all of the CSS and content and styles that are going to be associated with your page, and the header and menu and footer components. To give you an example then, looking at this page, oh, where's it gone? Come on, I want my presentation back. I don't know whether you can see it, but I can't anymore. Here we are. No, that's what I wanted. Resume slideshow. Here. Let's see whether I can get back to it. Here we go. No, it won't give me my spotlight. How ridiculous. Never mind. I will just point at it. So up here, oh, we'll go back a slide. We've got a header, we've got a menu, and down here we have a footer. All of that is part of your master page construct. The background of this is also the master page. And starting up here with the header of the table on this page, there we're looking at individual page content. And everything within there is within the table control on the page. Everything else around it is part of the master page. And if you were to customize it, of course, it would immediately be reflected on all of the pages in your application. That's also true if you're building a SharePoint application. You can nest that master page inside the SharePoint master page, as shown here. And just out of interest, if you were to look in the SPX markup for your page, you will see if this is the markup for a master page. Down here we've got this thing called a content placeholder. That's where all of your page content would sit for all of your other pages. Okay, there is an important point there that master pages can inherit from others. I've never done that. I'm not saying it isn't possible and it may not be useful. I've never found a need to use that, although you could if you wanted. So, what are the best practices for master pages? Well, you can create as many of them as you need. We always create, as an example, we always create a security master page. And the only difference, we copy the standard one, the only difference we have is we then delete the menu. So that when our security pages come up, we know that no one who hasn't authenticated yet is ever going to see any of the menu options available. Of course, you could hide them by making them secure. We just do that because we like to know that there's no chance that it could ever slip through. There are loads of different other scenarios in which you might want to generate different master pages. You can nest them. As I mentioned, we've never had a cause within an application to do that, but you can. They will include all of your standard content, but in addition, or if you get to a point where you're writing client-side code, it's great to write your JavaScript methods, assuming they're not huge in terms of their bandwidth size when you're downloading them. You can put them in the page configuration in a master page, so that then if it's a common piece of JavaScript, all of your different application pages will have access to that JavaScript method. So that's quite easy. But the page content would be specific to individual pages, and that's where things like your SQL data access is going to happen. Okay, I'm just aware that my control panel has disappeared. There we go. Okay, racing on. N-tier applications. We touched a little bit upon this as we began to look at the difference between classic ASP and ASP.NET. In effect, what we mean by an N-tier application is simply splitting up your application into different layers where each layer is concerned with its own function only, and that each of the layers interact with each other, but they don't necessarily concern themselves with how the other layers do what they do and how they go about it. Ultimately, there is then no reason why those layers even need to run on the same server. Again, we've never had cause yet to have our different layers running in different places, but arguably they could. So, starting at the very bottom of this N-tier application, we've got stored procedures. So that's literally, you may not be using stored procedures depending on which database you're using, but if you were, you could consider them to be a layer of your application. Your data access layer makes requests of your stored procedures for data, but it doesn't know how the stored procedures do what they do, and the data access layer may not be running on the same box at all as the database and the stored procedures. We've then also, in a way, almost before stored procedures, at the very bottom layer of your IronSpeed application, you've got the base class layer. So that's common code across your entire application. So that's down there too. Then we've got a data access layer. All the data access layer does is concern itself with how to get data for methods which have requested it above that layer. The principal layer that would be making those requests is the business layer or the business logic layer. Now again, the business logic layer makes requests for data from the data access layer. It doesn't care where it is. It doesn't care how it goes about it. But in there you would write generic logic, business logic that you want to apply to all of the data that comes back from the data access layer. We've then got code behind files. Now these use the classes within the business layer to receive and write data back to the SQL database. Again, they don't have any knowledge of how the business layer does its job. And then the layout layer or the presentation layer is at the very top of your application. The layout doesn't have any understanding of the function of the page. It doesn't know how it does what it does or where it gets its data. It just knows that as it's conforming and constructing the layout, it's going to get and receive data content that it's going to render in ultimately the HTML that's sent to the client browser. Looking at it in a little bit more detail, this is a slide taken from the documentation within Designer. So at the top, we've actually turned our N tiers the other way around now. And at the top, we've got the database. Then we've got pages which are being generated. We've got code behind files, and then the customizable code classes. So this is looking at it in a slightly different way. But the most important bit is to create this logical separation between the layers. And by and large, most of the customization that you will do initially if you're new to writing code will probably be at the presentation layer level. So you'd be writing in the ASPX code behind files and the controls code behind files. As you get more experienced, you'll realize and begin to make better and greater use of the business layer, the data access layer, and possibly even the base classes layer. By writing code lower down, of course, your inheritance structure will mean that you can make greater use of it across all of the other pages within your app. So you effectively have to write the same thing less often. So N-tier application, we're basically talking about this separation of presentation and logic and data. I'm not going to expand on what's there enormously. One thing that I did not mention at the very beginning of this, which I really ought to have done, is that you will get this slide pack automatically if you haven't already. I do apologize for not having mentioned that. Right. There's a slide here about MVC. MVC is an alternative method of building applications, whereas Designer is using ASP.NET Web Forms. There is also .NET MVC or MVC.NET, which is a different method of and application structure. In effect, this is just indicating that there are similarities between them. So whereas in MVC you have these concepts of model, view, and controller, they do reflect broadly to what you have within web forms as well. You know, the model is the equivalent of a business or data access layer component. View is the markup, and controllers are the code behind the markup. So, designer, I'd assume, I think you must already be high-speed users. But what does designer do for you? It's interesting to sometimes reflect and just remind yourself of all that it does do. So it does implement these best practices that we were talking about. So it builds you well-structured code that sits within this .NET model. The code gives you event handlers for all the different events within the page lifecycle, which you can start to customize. It does automatically implement some degree of AJAX in your pages for you by default. You can, of course, remove it. You can, of course, enhance it. It does give you access to master pages, and it does automatically build you an n-tier application under this kind of generically model view controller kind of separation concept. So it enables you obviously to then begin to focus on what your business requirements might be of your app, and then get you up and running with this .NET code model, such that you can begin to introduce your customizations in the appropriate places. Layout customizations, I'm sure most of you are pretty familiar with those. We can also use this toolbox to drag and drop these pre-configured controls onto the pages. And for simple code, you can use formulas, which then designer will generate the code for you based on the formula rather than you having to write code at all. In addition, you can start to write data access layer customizations. Now, again, initially, you don't even need to write code to do that. You can use the database properties sheet, and you can now use formulas in the data access layer as well. You can do global settings, Excel-like formulas in BMW, and now I can never remember what that stands for. Oh dear, and it's not a car. How awful. Do you know, a Batchmeister wizard. There we go. I have remembered. I'm pleased. So those are then global formulas which apply across your whole app. You can use application generation options for batch settings as well. And for business logic, you can obviously use the query wizards to customize queries. Now, most of these slides, I suspect you are already familiar with if you are users. So we've got some content on formulas and the beginnings of code customization. Now, there is another course on code customization which I would very strongly recommend you attend off the back of this. But that was an extremely whistle-stop tour through the ASP.NET code model, and I'm aware that it may be slightly daunting off the back of trying to cover all of that in 1 hour. However, I don't have all day, but I've clearly got some time to answer questions if you have them. So please do make use of the question box, and I will do my best to make sure that I can answer them comprehensively for you. No one has yet asked a question, which worries me slightly, and I hope it means that it's been okay and comparatively clear, rather than being a little bit too much to cover in such a short space of time. However, you may all be beavering away and typing questions into that box right now. Thank you, Terry. That's very kind of you. It does feel like quite a lot to cover for people in an hour. I know if at my early stages of getting to grips with ASP.NET, if had I attended this, I don't know that I would really have felt like I'd come away with a full understanding, but hopefully it gives you somewhere to start. Great. Well, there have been some very kind comments. Thank you. The .NET code model is an extraordinarily complex and large topic. So this is only obviously just to give you a very beginning point of how to start thinking about how to go and customize code. So please do not, if you have attended this thinking that you are going to start writing code and it has felt a little bit much, don't be sort of put off because it's a big topic. There's a lot to learn. Recommended resources, that's a good question. To be honest, the main thing I would recommend you do, personally, and this is how we started at our end, use Designer to build some simple applications. And I'll start again. I'm a firm believer in the fact that you can attend all the courses you like. You don't really learn something until you try and do it for yourself. So I could read countless textbooks about how to write ASP.NET code. Frankly, it's not until I try and do some customization and really get stuck into it that I ever feel like I really understand it. And that's true of anything, be it Paint Shop or Photoshop or anything like that. So if I'm honest, my advice to you would be get stuck in. Come up with an idea for a simple customization. Let's say you want to, there's going to be a value, a numeric value on a screen, and you want to set the visibility of a different control based on the value given. So if it's less than 50, it does appear. If it's not, then it does. That kind of thing. Come up with some simple ideas and try and write your code and think about where you're going to write the method for that code. Now, Designer makes that, to start with, a lot easier for you for two reasons. One, if you just in the layout editor, if you click on the control that you're going to be using to drive that code, then Designer will give you the commonly customized methods in the properties dialog on the right. So if it were a literal, for example, you'll see on the right that there is a set method. And then if you click on the set method, you can see what that code already looks like. And then you can think, okay, well, I can see how it's setting the text value of that literal. Let's say I wanted to, append something to the end of it. Then I can see how I would do that. So that's where I would start, because I'm a firm believer until you start really trying to write code, you won't really begin to really learn it. So here's a question. Hello, and thanks a lot. Thank you. My app has several data that's calculating the page based on session variables. How long are the memory lasts in sessions so the user doesn't see the wrong calculations? Great question. The session variables will stay there as long as the ASP.NET session is still open. So at some point, if you consider your HTTP stateless protocol, at some point the server gives up on you. At some point, if the server doesn't hear back from the user, the server says, you know what, you've gone. And if you want to come back and do anything, then I'm going to ask you to authenticate again. Now you can customize that both in your web config. You can set the timeout parameter, and then if you're running your app under IIS, you can tell IIS how long to wait before it times out and recycles. So you can change that. As long as they haven't timed out, those session variables are always active and will always be there unless you've removed them. And using session variables is really powerful. We do it a lot, but it can be dangerous because sometimes, unless you tidy up behind yourself, you might leave session variables lying around there that shouldn't be there anymore. So those are my two answers. One is the memory will be there as long as the .NET session with the server is still valid. But just make sure when you're using session variables that you are a little careful about removing them when you're done so that they don't stay there forever. I hope that answers your question. Are you planning to email us this webinar? Yes. Jill will, I believe, as soon as we get off the session, you should get emailed automatically by GoToWebinar with the documentation. If you don't get it, Daniel, then either email me or Jill and we can send it through to you. Valentine, yeah, no problem. Thank you. Right. Well, unless there are more questions, I will call it a day. I imagine if this is new to you, then your brains have probably had quite enough. Oh, in fact, Jill's just let me know. You will get Daniel, you'll get the slide pack about 4 hours from now. I think there's some kind of like buffering thing with GoToWebinar, but yeah, you should get it later today. Pleasure. I hope it's been useful. Don't be put off. It's easier than you think. Just get stuck in and start trying to make something work, would be my advice. Great. Well, thank you, everyone. I will sign off. Thank you very much again for coming.